Welcome to Lab 4. This time we are looking at using a new analysis tool on an old friend, energy conservation on the Atwood machine. Vectors are powerful, but they have a problem. You have to worry about directions. Even in 1D you have a negative sign. Wouldn't it be nice to work Newtonian problems without the vectors? Let's introduce energy. It comes in two forms. This is potential energy. It is the stored ability for something to do work. Being in a gravitational field gives us a potential energy of the mass times the gravitational constant times a height. If we have a spring, we would have a potential energy of 1/2 times the spring constant times the distance the spring is displaced squared. Kinetic energy is the energy of motion. It is the energy of moving objects. It is in the following form. The kinetic energy equals 1/2 the mass times the velocity squared. Notice that the velocity is squared. As velocity increases, energy increases faster and faster. We also have other forms, such as rotational kinetic energy. Energy is always conserved. It can change forms. If we can ignore things that take energy out that are hard to account for, like heat energy from friction, then we can just use the change in potential energy plus the kinetic energy change is 0. Then solve for V or whatever we need to know. No vectors involved. Let's start. Make sure you measure the height of the mass at the beginning. Also measure the pulley height. You will also measure the mass of the string. You'll need to have your scale well calibrated to measure such a small mass. The position is now included on your graphs. You will need to click on each graph and then scale to fit to scale both correctly. Don't worry if a strange artifact appears on the position graph. You'll measure 10 points. You'll get 1 time, 1 velocity, and 1 position from each point. Do all 140 calculations in Excel, so you'll only have to enter calculations 7 times. Put all 3 graphs, PE, KE, and E, on one sheet. Linear fit the total energy graph, and the other 2 are polynomials order 2. You'll also try correcting for the string kinetic energy and the pulley kinetic energy and including that in your Excel. You will not need to graph this. Does it make a difference to your result? What about pulley and string potential energy?